As I say, this DI box converts the unbalanced signal to a balanced signal. Sometimes with balanced signals, like an acoustic guitar, it might be a keyboard, a stage piano, or even a bass guitar. Sometimes with these instruments, the signal coming out is really hot, really strong. So what we need to do is reduce that gain coming in as early as we possibly can, and the DI box is the best place to do that. You'll find that there's a pad switch, might be called an attenuation button on it. That will knock out 15, 20 dB. You might have multiple versions of that with a 0, -20, -40 notch. Find the right one that works with your system and take it from there. There's no rhyme nor reason, I'm afraid, as to which instruments are going to have a stronger or a weaker signal. You've just got to work it out on the day. It might be that an acoustic guitar with a battery-powered preamp is going to be stronger signal than one without. But as I say, you need to try it out on the day and work out what's best for you. And don't forget the pad button and attenuate the signal if it's too hot. Now, in my experience, it can be too tempting just to run the volume of your instrument, your keyboard or your guitar, right the way down. Don't do that. Actually, you want to be running somewhere between 3/4 to full, depending on the instrument. That way you'll get the best tone, you'll get the best sound possible from that instrument. Then when it hits the desk, you've got a nice clean signal to work with, and you really don't have to do much more work. So when you're connecting up your keyboard or your acoustic guitar or your bass guitar into the DI box, as I say, make sure the volume on the instrument is 3/4 to full before you start to attenuate on the DI box. If the signal's too strong at 3/4 to full, then use the pad. Very often with DI'd instruments, we find that there's a buzz on the line. Most commonly this is caused by mains interfering with the unbalanced 1/4" jack leads. Doesn't really matter what the problem is or what's causing that. Actually, just flicking the ground lift or the earth lift button will get rid of that buzz and give us a nice clean signal to work with. So as I'm plugging this all together, remember 1/4" jack into the input, I'd like to actually talk a little bit about the cabling. Now, it's really important not to buy cheap cable. Cheap cables break really quickly and then they don't help you. One of the first things that breaks on a stage is going to be the cabling. So spend as much money as you can on good quality cables, get a brand name, not random supermarket stuff. So once we've plugged in all of our microphones and our DI boxes into the stage box on the stage, then we need to get from the stage to the mixing desk. Now, I said earlier that we do this using the multi-core. Now, it might be that your multi-core is already permanently installed if you're in a fixed venue. It might be that you're in a mobile church setup where you've got to do this every week. So the multi-core will have two ends. The stage box, which will live on the stage, and then the tails, which go into the mixing desk. Now, these multi-core tails are then numbered 1 to 8, because I've got an 8-channel stage box. Doesn't matter how many channels you've got, the point is get them numbered so you know which end is which. It saves no end of confusion when you're in a problem-solving situation. Regardless of how many tail ends you've got on your multi-core, you've got to make sure that they're being plugged into the desk in the right place. Now, this is where we need our crib sheet again. You need probably a copy on the stage and a copy at the desk. You're going to plug your tails into the right channels on the mixing desk. Make sure that you've got an easy life when it comes to your sound check. We've spun the desk round so you can see all the connections nice and clearly. You'll already notice that there's all sorts of cables plugged in already. Now, these are part of the DVD filming process, so just ignore those for the moment, and I'm going to concentrate on the bits as we plug them in. Okay, so I'm taking my multi-core tails and I'm plugging them into the desk. Now I need to find number 1. Of course, it's always the last one you find. And I'm going to plug that. It doesn't necessarily need to go into number 1 on the mixing desk. It might do for ease. Actually, that's a very nice way of doing it. But for today, because my microphone for the recording is in channel 1, I'm actually going to go into channel 7. So now that I've got number 1 going into channel 7, I'm going to work up and I'm going to go 1 to 8 into 7, 8, 9 and so on. So now that we've plugged in all of our inputs into the right places, we need to turn our attention now to the output side of things. Let's go remind ourselves of the signal flow. We're coming out of our desk from here, we're going into our amplifiers and our processors, and then out to our speakers and onto our ears. So as I say, we're coming out of our mixing desk and we're going into our amplifiers. Now for today, my amplifier's got a built-in processor. This processor is handling all the EQ and tonal adjustments that I might want to make to my speaker system. It might be that in your context, you have a separate processor unit and amplifiers, in which case the signal flow is going to be from the desk to the processor and then into the amplifier. Now I'm going to connect it up. So we're coming out of our mixing desk here, and this time, instead of going boys to the board, because it's an output, I'm going boys away from the board. Important that you get that the right way round. Now it might be, as I plug this in, that you've got an integrated mixer amplifier unit, in which case don't worry about this stage, it's not going to be appropriate for you. Female's gone from the desk, male's going into the input of my amplifier. Now the length of the cable that links my desk to my amplifiers doesn't really make much difference. This is just a standard XLR lead that I've used. On the back of some amplifiers you might have a jack lead, or you might just have bare end terminals. It doesn't really matter what it is, as long as it's a nice, consistent, nice and clean and there's no shorts. So now that we've connected into my amplifier, I need to go from the amp into the speakers. Now the system I've got works on Speakon. Some people call it NL4. It's the same thing, so don't worry about the different terms. Let's call it a Speakon for ease. The Speakon cable has been around for a little while now, but it's becoming increasingly more popular and is almost at a point where it's now the industry standard. The reason why we like Speakons is because they have locking pins that twist and click into the socket, which mean that it's a very reliable connection. It's not just going to pop out at the drop of a hat. Also, the Speakon connector is designed to handle the heavy load coming out of the amplifier driving the speakers. So now I'm going to connect it up. So plugged into my amplifier, and then of course the next cable goes onto my speaker, so I'm also going to connect that one up. There we go, done. So now I've connected everything together, I've got a complete signal flow, going from the mic or the DI, through the multi-core, into the mixing desk, out to the amplifiers and processor units if you have them, and then onto the speakers. So now that that's all connected up, the last thing I need to do is plug together my stage monitors. Now what I'm going to do here is I'm going to come out of my mixing desk, but rather than using the main left-right outputs of my board, I'm going to use the auxiliary outputs. For today, I'm going to plug into aux 1. Now, on this desk, if you're really astute, you'll notice that the aux output's a 1/4-inch jack, but my stage monitors, I really want to run them in on XLR. So I've got a little converter cable here that's going 1/4-inch jack to a male XLR. Then I can plug in a normal XLR and run away to my monitors. Now the reason I'm not having to use a DI box as part of my monitor outputs, my aux outputs, is because it's already a balanced signal coming out the desk. So there's an important thing to remember there. Stage inputs are going to be unbalanced. My outputs from my desk, whether they're presented on jack or XLR, they're always going to be balanced. I'm going to take my XLR and I'm going to plug it into my monitor now. It's important to notice that the monitors I've got here are actually powered units, by which I mean the amplifier module is built into the speaker. Now for me, for the live PA system, I'd rather have separate amplifiers and speakers, but for monitors, powered speakers or passive speakers with a separate amplifier doesn't really matter as long as you know which one you're using. So now I've connected my entire system, from mic through the desk to the speakers and all my stage monitors as well. Now that I've connected everything, and only now that it's all connected, should I be turning things on. Now, which bits do I turn on first? Well, really you should be turning on the mixing desk first, and then the speakers, not the other way round. The reason for that is if you turn the speakers on and then the mixing desk is going to push a load down the cable and it's going to make the speakers pop and you run the risk of blowing them up. Now, of course, once it's all connected together, it doesn't guarantee that everything's going to work. So we need to put our problem-solving, troubleshooting brain on and think through the signal flow from start to finish. If we have a problem, we know we're getting sound into the desk, but we're not getting anything out, then we know that the problem is going to be downstream of the desk, i.e. it's going to be amplifiers to speakers. If we're not getting anything coming into the desk, there's no light showing, we can't hear anything on our headphones, then the problem's going to be before that. I find, as I said earlier, one of the easiest mistakes to make is that you've mispatched something or that maybe a cable's broken. That's always a great place to start. Remember, the signal flow goes mic DI into the multi-core, onto the desk. From the desk, it goes to our processors, amplifiers, and then onto our speakers. So let's put this into context. Maybe you've got an acoustic guitar that's not working. Well, I'd always check the battery first, because if you've got no power in your battery, you're not getting any sound out. Especially if you've left your jack lead in for a great length of time, it's going to drain your battery right down to nothing. So check the battery first. From there, make sure the volume on the guitar is turned up, 3/4 to full, as we said earlier. Then I'm going to check that my jack lead into the bottom of my guitar and into the DI box is correctly connected. So if we know that everything's connected into the DI box properly, it might be that the cable's failed. So an easy way to check that, there's two things you could do. You could try a new cable, or you could take the same cable and plug it into another DI box onto another channel in the mixing desk just to make sure. Assuming that all the connections into the DI box are seated properly, it's also worth checking to see whether your DI box needs power. It could just be a straight battery that feeds the DI box. Equally, it could be phantom power that's coming in from the mixing desk. Check that it's on the mixing desk, and also check whether your DI box has a phantom power on-off switch on them. Very few do these days, but it might trip you up. I've been there myself. So the next thing we need to check is the stage box and the multi-core. If you've got a permanently installed system, it's very unlikely that your multi-core is going to have been repatched or disconnected in some way. Of course, in the mobile church setting, it's highly likely that you've had a mispatch. So get somebody on the stage to check those ends while you're getting your crib sheet out and checking the desk as well, check everything's patched in properly. So it might be that everything's connected properly, but the mixing desk isn't working. Now, unlikely, but it does happen. The easiest way I have for checking that is to get a CD or an iPod or something just to play out of the mixing desk, and then I can check that all the amplifiers and the connections to the speakers are working properly. If I'm getting sound out, then clearly the challenge is before the mixing desk. If I'm not getting any sound out with just CD playback, I know that the problem is within the desk or out to my amplifiers and my speakers. It may sound obvious, but if you need to check the desk, I'd always make sure that it's powered up properly. From there, I'm going to check that the gain on the channel is up. I'm going to check maybe that the fader's pushed up. Equally, it's worth checking whether the channel's muted or unmuted. It should be unmuted. Some desks have an on-off button rather than a mute-unmute. Just check that that's set correctly. From there, you want to make sure that the audio is being routed through the desk internally, so it's going to the main left-right outputs. Make sure that those master faders are up as well, and indeed unmuted if you have them. It might be that the problem's within the amplifier and the speaker system, in which case check that the amplifiers are on, check that all the connections are seated properly. It sometimes helps to unplug and replug. Of course, make sure that the amps are turned off when you do that, so you don't put any bangs into the speaker system. Equally, then you can go to your speakers and check that they're connected properly as well. So in a problem-solving scenario, always work through in a logical, orderly fashion. Start at the input at the very beginning, and then work right the way through to the speakers at the end.
In this section, we're going to be looking at best ways of setting up a sound system. Now, the first thing I hope you don't have to do is what I'm having to do now, which is to use a mixing desk upside down. That's kind of not really the way it's been designed to be used. But I'm going to go through some fundamentals on what is the best way to set up my sound system, from microphone to mixing desk, out again and into amplifiers. In terms of talking about speakers and amplifiers, we've really got two ways of going. Here I've got an amplifier which is an L-Acoustics amplifier driving an L-Acoustics 8XT speaker. This is all good, but sometimes a speaker manufacturer will put the amplifier inside the speaker. We might refer to that as an active speaker, where the amplifier is actually inside it. So which is the best way to go? I have particular opinions on this, and first of all, if we're thinking about fixed installations, I really like the idea that the amplifiers are maybe in a technical rack in a cupboard or a back room, somewhere out of sight, and not actually inside the speaker. So my preference for installation work is that the amplifiers are somewhere and the speaker is mounted wherever it needs to be mounted. Now you might be asking me, why is that? Why would we separate the amplifier from the speaker? The kind of theoretical idea is the closer we can make the amplifier to the speaker, the better it is, because we can make the copper run shorter. So the idea is that if I want to move something with some kind of energy and power, it's much better if the thing I'm influencing is very close to me and electrically very close. However, if we separate these two things using copper, then there's this thing we've got called damping factor. It's like trying to control a speaker, but instead of having a really stiff control of it, we're trying to move it with a kind of a rubber piece of string. That's the reason why people like to bring these two things together. However, this idea has its disadvantages. I mean, I do not like doing installations where I have to now distribute the signal that the speaker needs and a power source for it. That's going to have to be run to every speaker, signal and power source. And also in the modern era where these things are network controlled, we probably have to send a Cat5 cable there as well. And that's going to get really messy for your installation. So my preference for fixed installs is that you actually use a separation of the actual speaker and the power amplifier. We put the speaker, which is a low-tech electromechanical device, we can fly that up high, we have no reliability issues, but we put the electronics, if you like, somewhere where we can get at it, somewhere where we can service it safely. So this idea that it's a really good idea to put the amplifier right inside the speaker box is kind of esoteric, and in my opinion, it's a battle that you just don't need to win, and it brings a lot of disadvantages with it. I don't really want to put DSP electronics, digital processing, and complicated technology inside a wooden box that shakes. For me, that's going to be a bad idea for long-term reliability. So at SFL, our preference is that we separate the amplifier from the speaker. So what about mobile situations where you have to put your PA away and keep getting it out again? Well, again, the idea is that there is some kind of convenience in having the amplifier inside the speaker. Now, I do an awful lot of outdoor work. I do mobile systems. Part of our business is that we're a hire company doing productions all over the country. Now, putting the amplifier inside the speaker, you might think makes a system simpler, if you like. But there's nothing funny about a system which has got power running into it when the rain starts coming down and the back of your speaker is getting wet with a mains lead going in there. So in our opinion, systems where we have to distribute power are, number one, probably not as safe as if we have the power amplifier in a rack which we can easily protect from the environment. So we've discussed the fact that we're going to have probably a separate amplifier and a speaker. So something that's really important to us is the copper that connects the two. Now I'm going to go over here and just unplug the speaker, and here you'll see a speaker cable. And the thickness of the copper that's in here is quite important to us. And you want to be using a minimum of 2.5 millimeter cross-section copper. A lot of people will install 1.5, and in my opinion, it's just really not thick enough to allow the amplifier to properly control the speaker. We need the ability to create a very strong connection path between amplifier and speaker to maintain good quality sound, especially at low frequencies. So there's nothing particularly expensive about this cable other than the fact that it needs good thickness. It doesn't really, don't worry too much about oxygen-free this and hi-fi speaker cable that. In the world of PA, all we need to do is provide the maximum copper cross-section that we can get from the amplifier to the speaker. I'll say again, 2.5 millimeter cross-sectional area. Now, for reasons of neatness, it's probably likely that the amplifiers are going to be in a separate place to the mixing desk. Normally, the amplifiers will be sited down towards the stage end, and the mixing desk obviously will be down more into the depth of the venue, more representative of where we would like the mixing engineer to be. The mixing engineer needs to be in the congregation, and then we need to put the technology at the other end of the room. In this way, we can minimize the length of the speaker cables. I've mentioned that we want to use good quality thick speaker cable, but we do want to try and minimize that length. We want to try and avoid having 150 meters of speaker cable between the amplifier and the speaker if at all possible. You know, I would be happy with a medium-sized sound system. I'm talking about something which is providing audio quality maybe to a congregation of 500 to 1,000. I would be quite happy running 2.5 millimeter copper, maybe for a maximum of 50 meters. If you go over the 50 metre into the 100 metre area, you might want to consider the usage of maybe 4mm cross-sectional copper to connect to those speakers, especially if they are your main speakers. If they are smaller fill boxes, a little bit like the 8XT that we've got here, if it's a smaller fill box, then you could probably consider using 2.5mm copper right to 100 metres. Now, I will remind you that in previous sections, I think we've discussed with you the idea that your speakers need good height, and by giving them good height, we are attenuating the level to the very close listeners. That means that the people with close proximity to the speakers are not being stressed out by an overuse of volume in those positions. Remember that as we go high, we also probably want to keep reasonably flat. Please avoid the temptation to over tilt your speakers, because as you do that, you're destroying the very effect of sending them high in the first place. We mentioned maybe a down tilt of maximum of 5 to 10 degrees, just to keep some of the energy from going into the ceiling areas. I would also remind you that we want to try and either have the speakers very close to a wall surface, or in fact a good number of meters away. We don't like this kind of 1.5 to 2 meter spacing between a speaker and a hard reflective surface, because then we start to get reflections that through comb filtering give us strange tonality from the speaker. So we like good close proximity to a surface, or maybe 2 to 3, even 4 meters away from that surface. This 1.5, 2 meter proximity is going to give us problems with tonality from our speaker system. Now we come to the position of this thing, the mixing desk. Now, generally, there's this idea that we want to try and take the tech and we want to hide it in some way. We don't want it to be seen. But also, as an opposing factor, we really want the person that's mixing sound to have their head and their ears in the same environment as the congregation. So number one, please, if your congregation meet where most of the time, 80% of your congregation are downstairs, and you only rarely use the balcony, it's very tempting to put the mixer up on the balcony because it gets it out of the way. However, most of the congregation are downstairs, and therefore I would like the mix engineer to be downstairs. Remember, this is a musical process where we're trying to mix sensitive to the people around us. What is the point of putting the person that needs to do that in a completely different space to the people for which he's serving? So please, can we avoid the idea of putting this in some kind of isolated glass box behind a glass panel hidden at the back of a venue? I would like to see this maybe 2/3 of the way down the venue. I agree that you maybe want to move it to one side. I'm not too particular about being in the middle of something, because a lot of my congregation, when I'm mixing for them, are not in the middle of anything, so why do I need to be there? But I do need to be in some kind of a representative example space within the venue that I'm working in. So here I've got a Allen & Heath GL 2400, I think it is. I've not seen one of these for a little while, because most of the things I mix on nowadays are digital consoles. However, we use these kind of things in training because it stops us focusing on the architecture of the user interface. An analog console is a very nice thing for you to learn your basic mixing skills on. It is therefore likely that your mixing desk, even though it has many more channels than this console has right now, probably won't be any bigger. So really this thing is not huge. It need not take up the area of a table any greater than this. And so the need to hide it away, I think, is not necessary. A console like this that maybe has 20 or 40 incoming channels of audio will have 20 or 40 of these things. These are XLR cables. They're carrying the signal into the mixing desk. Now, that can make a bit of a rat's nest at the back of the console, and I can understand why you'd want to hide that away. These things can be put into boxes or structures that do hide that cabling. But I would remind you that in the modern era of digital mixing consoles, it's likely that all 40, even 60 channels of this audio are being delivered on a single Cat5 cable, in which case your whole installation infrastructure is made much simpler and much neater. So I'm hoping that when you plan your next installation, that you will allow the mixing desk to go in a representative place within the body of the congregation, so that the mix engineer can do a great job of providing great sound to the people that are around him. Okay, so next I want to talk about this subject which I will term gain structure. And gain structure is really the most important thing for a sound engineer to get to grips with. The idea of gain structure is about the control and the manipulation of sound pressure level. So gain structure, what is it? Where does it start and where does it go? Well, first of all, the first idea of gain, of volume, of sound pressure, is really being formed in my own mentality. I have made a decision on how loud to perform. I have made a decision on presenting to you that I want to use some kind of energy in my voice which is communicative in some way. I am not talking to you in a weak and feeble way. I want to deliver information to you with confidence and with energy. So the first place in which volume is generated is in the mindset of the performer. And this is, in a way, the most important base level of energy that we hear as a sound engineer. Now, in effect, in a large venue, even though I am a confident presenter, I hope you would agree with me, I'm trying my best, but even though I'm trying my best, the venue might be too big for me to deal with. And in that situation, we're going to need to use a microphone to give some sound reinforcement to the performance. So I've got here a typical microphone. It's a Shure SM58. It's probably the most common microphone in the world. And if I screw the top off it, what you'll see is that its diaphragm, which is here, is a vibrating, small, very lightweight piece of mica, which has got a coil attached to it, and that coil vibrates in a magnetic field. It's a bit like a speaker, but in reverse. If you think about what a speaker is, it's exactly this, but it's just bigger and the other way around. The deal here is we vibrate the diaphragm and it makes a little electrical signal. If you think about a speaker, it's exactly the same thing, but the other way around, but we provide the electrical signal and it provides the vibration. You can really think about a microphone and a speaker as being doppelgangers of each other. What I want to show you is that the diaphragm is not exactly at the front of the basket of the microphone. If I hold it in place, I'm hoping that you can see that it's nearly 3/4 of an inch. Let's call it 3/4 of an inch in the depth of the basket. So I'm going to pop this back on here. Now you know where it is. There you go. Now, what I'm going to suggest to you there, that the diaphragm is nearly here where the ring of the microphone is. So even when I hold the microphone directly to my lips, where it's touching my lips, I'm still this far away from the active part of the microphone. There's a pop shield inside here, which is a foam shield which stops the P's hitting the microphone and making that unpleasant kind of bassy impact sound. So I'm going to turn this microphone up for you so you can hear it. It's on the mixing desk here. It's actually coming out as a sound reinforcement from this speaker, so it gives me a kind of a reality injection of the fact that I'm talking to you now through sound reinforcement. What I wanted to show you is this idea of doubling of distance. And what's going to happen is that every time I double the distance from the microphone, I'm going to lose 6 decibels from the sound pressure level, to the point where now we can no longer really hear the SM58 compared to my own microphone that you're probably hearing on these teaching DVDs. So this distance is critical for gain structure. We said that the first place that we generate gain is in the mind of the performer, but once that energy has been set, the second place we generate electrical energy is by making sure that we've halved and halved and halved again the acoustic distance to the microphone to make sure that we get the maximum possible signal without having to use gain on the mixing desk. The first place we need to increase volume and confidence is from the voice itself. The second place we generate volume and confidence is by good proximity of the microphone to the voice. So a lot of people will call this microphone technique, and for us, good microphone technique is that your lips should be touching the microphone. This gives us a very consistent volume. We know exactly what that will sound like, and it's very easy to return to every time we can obtain the same volume without any variation. Now, I do appreciate that if somebody is preaching they're probably not going to be comfortable to use this very tight coupled approach. This would be more applicable for a lead vocalist or a backing vocalist. A preacher might be using a microphone a little bit more away from their face, where they want to make sure that people can see the facial expressions and the movement of their lips, often also important for people with hearing difficulties who find the actual lip sync and the ability to see the lips move as being a really important part of how they can engage with what's being said. Not only does a microphone get louder as it comes towards the source, but also we get this thing called proximity effect, where the tonality of the microphone will gain in bass performance. So if we have a vocalist who is using a microphone at varying distances, then you will find that not only is the level changing, and you will be trying to chase that on the mixing desk, but you'll also find that the tonality will be changing. Having said this, I know that we do cover this in other sections of the DVD, so I'm going to start to move away from microphone technique and get more into gain structure. Let me remind you again, the two most important places this gain structure comes from is number one, the mind of the performer, number two, the microphone technique that is being used to generate the signal to the mixing desk. So now, having formed these two ideas, the most important parts of gain structure, I'm going to take you on a world tour of gain structure. And it starts in here, it gets to here with good microphone technique. We then basically make a signal, which is a balanced line. If you look down a microphone, you will find 3 pins. This creates a balanced line which is immune to noise. That's really important to us if we're using very long cable runs. Sometimes you will find that a guitarist will need to run right down the length of the multi-core, maybe with an acoustic guitar, and in that case we use a DI box, and I know that we've covered this in other sections of the DVD. So we create this balanced signal, we send it down, good quality, twisted pair microphone cable, which is shielded to stop the noise getting in. And it's a balanced line, so if the noise does get in, we've got good ways of rejecting that noise when we get to the mixing desk. At this point, we take our microphone, we plug it into the mixing desk, and now we start our electronic amplification process, which carries on the story of gain structure. So we're inside the mixing desk, and we started to think about how the mixing desk controls gain. We hit the mixing desk, and the first thing you'll see here is there's a line level or mic level switch, which is sometimes called a pad. In this case, it's called a line. It's got pad in brackets underneath it, so that's quite helpful. Now, there's a suggestion here that if you have a line level signal, this is the sort of signal that would come out directly out the back of a keyboard or directly out the back of an acoustic guitar. That's quite hot. It's quite a powerful signal compared to a microphone, and so it's likely that we would have to put the pad in. What would happen, you would know if you need to put the pad in, because you would be getting so much volume that you would be turning it down and turning it down and turning it down, and you still can't get it down enough. You might be seeing an awful lot of metering, a lot of red lights, and you are reducing gain to get rid of this, but you can't reduce any more. At that point, you would put the pad in. In fact, I would suggest that if you are only in this area of the gain knob where you can't really turn it up at all before you get too much signal, then it would be appropriate to have the pad in, and then we can bring the gain knob up to some kind of reasonable setting. So in terms of gain structure, we've got the pad, which generally is going to be turning things down or up by 20 decibels, depending on whether it's in or out. And then we've got the main gain knob, which is controlling volume. You can hear that right now, controlling volume. I'm turning up the speaker, the microphone into the speaker using this. I can also pad it down, and that drops 20 decibels. You'll notice if I put the pad in, I'm having to turn up really high because this is a microphone and it is at microphone level. Can you see that if I turn right up hard like this, I am not presenting the desk with enough signal, or I have my pad inappropriately set. Be very careful. The pad is in right now, so everything is 20 dB quieter. If I was to release the pad, suddenly 20 dB would be shot into the PA system. You might get some really nasty feedback doing that. So if you are going to release a pad, turn down first, release the pad, and then refine the position of the gain knob to give you what you want to hear. In general, if you're using vocal microphones or any kind of microphone that you're using in contemporary music, you're going to find that most of your microphones will have the pad off. So the kind of things that will probably want the pad on will be the output from DI boxes, maybe when you DI an acoustic guitar or a bass. Or if you were to take the DI out of the back of a bass combo or a keyboard combo, those things are generally very hot. They are at line level, or maybe the input